Welcome to question 2 of the 2010 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 2a we're asked to find an antiderivative of cos of 2x plus 1 with respect to x. So rewriting that question, we just have the integral of cos of 2x plus 1 dx. And then looking at the formula sheet that's provided in the exam, we can see that the antiderivative of this is 1 divided by 2, where this division by 2 occurs because of the number multiplying x inside this linear term within the cos function. And then cos becomes sine, and we still have 2x plus 1 inside that trig function. And then we would usually have a plus c, which is a constant of integration. However, because we're only asked to find an antiderivative, we could have just let that plus c value be 0. So that is the answer for part A of this question. So as you can see from the examiner's report, 3/4 of the students got that question correct. And the comment in the report is that that was well done by the majority of students. Another thing to note was that because the instructions said to find an antiderivative, the plus c value here was not necessary in this question. So for part B of question 2, we're asked to find p given that the integral between 2 and 3 of 1 divided by 1 subtract x dx is equal to log e of p. So the first thing we're going to do is take out this negative factor from the denominator of the fraction. So we're going to rewrite this integral as being the integral between 2 and 3 and the negative comes out, and we're going to have 1 divided by, and the bottom line would now simply be x subtract 1, and that is still with respect to x. So if you expanded that negative back through, you'd still have the original equation. However, we can now more simply deal with this integral statement. So looking at the formula sheet that's provided in the exams, the antiderivative of this would be negative log e, and then we would have x subtract 1 in here, and of course the terminals are still going to be between 2 and 3. So to evaluate that, we're going to put 3 into the antiderivative and then subtract away the antiderivative evaluated at 2. So to complete that, we would have negative log e, and then it would be 3 subtract 1, and then we're going to subtract away from that negative log e of 2 subtract 1. So simplifying this down, we would have negative log e, and the first one, 3 subtract 1, would be 2. And then we have subtract, which would become plus, and the second term would be log e of 2 subtract 1 is 1. However, we know that log base anything of 1 is simply 0, so the only term remaining is this negative log e of 2, and we have a log law that says p times log base a of m can be written as log base a of m to the power of p. So for this question, it means that this can be written as log e of 2 to the power of negative 1. And hopefully we know that anything to the power of negative 1 is simply the reciprocal. So 2 is going to become 1/2. So therefore, the value of p, which is what we were asked to find, is simply equal to 1/2. So that is the answer for part B of this question. So from the examiner's report, we can see that only 30% of students got full marks for this, while 20% got 0 marks and 43% only got part of the way towards the answer. So you can see the working here that VCAA has used to get p is equal to 1/2, and one comment they made is that many students did not include the negative sign, which was essential in here, to answer this question correctly. And there were a number of incorrect responses, such as the one that's listed here, but that is particularly relevant to the old study design when the modulus function was still a part of the course. So that mistake may not be as prevalent in the new study design.